edition of DEF CON. Those the hours that starts at 8 and never end. Um, my name is Ofir Arkin, and I will be speaking today, cool, about infrastructure discovery. Usually, a lot of people at DEF CON talk about how to break things, how to search cool stuff, how to take something and to break it. Most of the people that I know from the world that actually do network security, they are in charge of how they maintain their stuff. Um, this talk is basically going to speak about what kind of knowledge and how we get it from an enterprise network. It means that how do we acquaint ourselves with our users? How do we acquaint ourselves with the machines that operate on the network and with actually what is being done on the network? Usually if you look at the DMZ, then the DMZ is usually well fortified. We have most of the things are already there. Most of the firewalls that we have can block 90%, 95% of all attacks. We can put another system. We're like 99% protected. So the guys that understand how to defend themselves, they're actually pretty good doing that. And usually it's not that hard to do that. You just need to understand what you need to do, what you need to defend. That's sometimes another interesting question. The talk will be, well, I'll try to do it really fast so they can take one of those walls down and have the bowl here. We're gonna talk about why do we need infrastructure discovery, why active network discovery and passive network discovery are not that good, and what can we do, and I will show you, demonstrate you a new agentless real-time approach that enables us to have real-time information about our infrastructure and to allow us to do monitoring and auditing. A bit about myself, I'll do that pretty fast. I'm the Chief Technology Officer for Insidex. I'm also the founder of the security group. Most of you know me from my previous work, ICMP Scanning, Xprobe 2, and other things that I've published along the years. I'm also a member of the Voice over IP Security Alliance. Let's go. Okay, so you have an enterprise network. It's large, it's complex. A lot of things operate there. Usually it may be combined from multiple networks in different locations. And basically there are a lot of nice things that operate on the network. Some of those are mission critical. Mission critical is a nice definition that says a lot of things to different people. At the end of the day, we need those systems to work in order not to have some financial damages. Another nice definition. But at the end of the day, mission critical means that if those systems are down or if those systems cause some kind of a problem, it means that other systems suffer. So for some, mission critical, it means the servers, the networking gear, and for others it means also the desktops. If you had suffered an outbreak of a worm that hit a desktop and that desktop brought down your switch, your access switch, or other things on your network, then that desktop is mission critical to you. IT basically needs to take care of a lot of things that actually important for the regular operation of the network. We need the network to be available, we need the elements to be available, we need to maintain the security of the network, and of course the availability of whatever is on the network. So basically IT has a ton of work. Usually IT will, the CIO will come to IT and say, well, you have enough people that needs to maintain what we have. Just invest in smarter management systems. So IT needs to identify what are the assets, what they mean to the organization, their properties, their roles, the different interdependencies, what will happen if one of them will fail, how that will affect the IT organization and the business process, to understand the importance of those assets. A lot of boring stuff, which at the end of the day is very critical to be done, because if we're not doing this, we don't stand a chance to actually run an IT organization. And we have here a lot of things that relate to provision the network, provision the elements, know what we're defending, knowing what we're managing, detect and troubleshoot issues, defend our assets, eliminate those systems that actually pose a risk to some of our assets, and of course do other things like prepare for the worst, do disaster recovery management, and a lot of other things. The problem is that in order to do all of those things, we need information. We need information about the network layout. How does our network look like? Yeah, another worker at your local burger store. Okay, so we need to know the topology. We need to understand what are our resources, and we also need to understand what are the elements that we actually need to manage and to secure. So at the end of the day, we need intimate, complete, and accurate knowledge about our infrastructure. And without this kind of knowledge, it will be, well, we can't actually do management and security. The problem is that the information that we need is either unavailable, partial, or incomplete. This is because this kind of information is not easily produced. Some people in our organization may had that information, but they left. Some of this information is dynamic, and some of the systems that we use in order to maintain that information are insufficient. So at the end of the day, if we don't know the network, we can't actually manage or secure it. This brings us to this slide, to the result. The result is that we always work at the 80-20 rule. And you know what? The 80-20 rule is really bad when you do management for networking and for security. Because you know what? The 80% that I know of, you know what? I'm managing them right. I'm doing all the things that I need to do for them right. But those other 20% that I am able to uncover, that I don't know what they are in my organization, those that actually pose the highest risk for me. Well, the highest risk can come from a compromise. The highest risk may come from auditing perspective. The highest risk may come from a lot of things, but at the end of the day, I don't have control. I cannot understand what I have, and I have full sense of control and full sense of security. And when I have these, then it's all downhill from there. So along the years, there were several technologies that were trying to solve the issue of knowing the network. And basically, what they were trying to do is they were actually trying to have the topology of the network, understand what are the elements that reside on the network, what their properties are, and they maintain this information up to date. It seems that this is a definition that it's very small, right? It contains everything, but it has a lot of problems in it. Doing network topology, if some of you are using network management systems that claim that they do this, it's a hard thing to do. It's not that easy. It's not that easy to say which switch is connected to another if you do not use CDP or other proprietary protocol. It's also not easy to produce the information about what actually lies on the network. So, let's start with one of my favorites, active network discovery. With active network discovery, basically we send some packets to the network and we hope that we'll see some responses from those elements on the network, and sometimes according to those responses or the lack of, we will draw some conclusions about those elements. An active network discovery system will try to get information about the inventory, meaning the elements, their properties, information about network services, the configuration, the topology, and if this active network discovery is able to do vulnerability assessment. Usually it will be installed on a single location on the network, although you can install it in multi-points, and will scan the network from that point. The way this can actually work is that an active tool can be fed with a list of IP addresses he needs to scan, or a list of networks he can scan, or that the active network discovery tool will try to do that automatically by querying local elements and drawing that information from them. For example, HP OpenView, Tivoli, and other management systems go to the router, take the routing table, understand there are other networks they might need to operate against, and continually trying to detect other routers on the network, taking more and more IP address ranges, and from there trying to enumerate all the information about the network. The strength that active network discovery has mainly relates to the ability of active tools to completely control what they're asking for. They send the stimuli out so they can understand, well, we need this information from that element, we need that information from another, and they can also control the initiation of the scan, and also they can control the pace the queries are being sent. Technically speaking, if we're not having any kind of obstacles between the active network discovery to the target, an active network discovery system can scan entire IP address ranges. The weaknesses are a lot. I'll try to do something with the refresh rate pretty fast. Sorry if I can fix this. No. The weaknesses, well, the first one is that the discovery that will be done will be incomplete. This is since network obstacles on the network will prevent packets to reach their targets. And if you have network-based firewalls, host-based firewalls, those Windows XP SP2 that you installed and forgot that by default they have firewalls and now you're unable to manage, not enabled devices, load balancers, and other things that you put on a network will prevent the packets to reach their targets, and basically this will create black holes of information. So from a network that has a lot of elements, you'll discover that you have a very small network. Well, it's not true. Sometimes you'll need some type of information to be enumerated from those elements in order to draw your conclusions. And you know what? Sometimes those services will not be operating on those elements, and sometimes they will not be willing to speak to you. So for example, if you need information from the Windows remote registry and you have the administrative rights for the domain, but the system is not a member of the domain, guess what? It will not help you. Also with SNMP, if you don't know the community strings of those routers that you want to enumerate, at the end of the day, you can't draw the information from there as well. The process is very slow, it's time consuming. By the time you get the information that you get is obsolete. This is because it's not real time. It also consumes a lot of network bandwidth, and it might take some elements down when it's actually doing the process. This is because sometimes it will overwhelm the networking elements between the scanning system to the target with the amount of traffic it produces and will cause an out-of-service condition. So some folks went and say, well, you know what, we can do scanning at off-peak hours. We'll take our active network discovery systems or management systems, we'll take that to off-peak hours, and that will do it. Well, wrong, because you can't actually define what are off-peak hours, and sometimes during off-peak hours there are some crucial processes that actually are being done, like backup, restores, some reporting on your databases. So actually the process of probing those elements might not actually can be quantified to a certain time, and sometimes it may take longer than you actually know. Telecom company that I know runs HPOV against 4,000 devices. It takes them 24 hours to complete the scan. Well, this is absolutely no-no if you're doing that against your operation network. So there are others who said, well, you know what, we'll do the scan faster. So we'll narrow the time that the scan needs to be done, and we'll finish it faster. Well, it's a good thing in theory. How many of you know Nmap? How many of you use Nmap? Cool. So someone can tell me what's the usual time that Nmap scans an element on a local network? 3 seconds. How many packets does it send? 1,500. So let's see. If I scan my network, 3 seconds per element, 1,500 packets, that's a very bad thing to do. Try that on your local printer. Believe me, my printer cannot withstand that kind of faster scan. So whenever someone from my engineering team goes and use Nmap by mistake, or I know that I can't print, so I need to go to the printer, power it off, power it on, and then use it. And then see who's the engineer that was trying to play with network discovery on my network. So at the end of the day, this will cause disruptions on your network. Scanning faster is not the solution. And we go to the stability issues, which are the major ones. Basically what those will cause, they will cause your machines to be unstable, like print servers, printers, other elements that cannot withstand a lot of traffic, and all of those will, at the end of the day, will be denied of service. It doesn't help if I play with it even. Sorry about that. Um, this is because either the pace of the scan, the usage of non-RFC compliant packets, um, the type of information enumeration you're using. So if you're thinking that you can do network topology by taking the ARP tables from the routers, believe me, this is something that you do not want to do. You make the routers choke, you don't have connectivity to nowhere, and this is the last time that you will run an active tool on your network, because your CIO either will fire you or will tell you this tool does not run on my network anymore. Some folks just forget that when they're doing vulnerability assessment, they shouldn't use those tests that actually cause denial of service. It's a bad thing. Against production machines, it's not a good thing as well. So sometimes the stability issues will arise just because there's the element between you and the scan target cannot withstand what you're doing. If you remember some of the old checkpoint denial of services where someone scanning from the internal network, someone on the other end, what will happen is that all these state tables will be filled with information. They will wait for the timeout for the connections, but the state table is full. It cannot handle other legitimate connections. So what you have is a perfect denial of service to someone from and the inside doing a pen test did. Also switches, they will be overwhelmed by the number of connections and they will die. Believe me, it's very nice to, for example, I'll mention that later. If you span too much on a Cisco 3550, it's a party going on. It will send all packets all over the place. You'll never understand networking in your life. You should see that. So at the end of the day, the result is that some of the networks that you have may be declared as active scan free. You'll never be able to scan them at the end of the day, because all of those other admins, the app admins, the network admins will come and say, well, we can't do this because you know that at the end of the day I'll have denial of services and I don't want to do that in my production machine. So there's a lot of production networks that are unable to be scanned because of these things. Well, nothing I do helps me with this. So we have some parts of your network unable to be scanned because people are fear about active network discovery tools, or previous history has proven them right about that. So some people suggested that active scanning can be done in a different way. Let's have multiple machines scanning from the same place. It's actually called a cluster. Guess what? This doesn't help you actually, because the scan is now distributed among several boxes. They scan the network at the same time, and they send actually more traffic to the network. So all of your denial of service conditions, all of your other problems are still there, but nothing is really a plus. Others were suggesting to put a proxy in each IP subnet or broadcast domain. This is actually a better idea because you can actually scan faster and you do not need to go through routers. But at the end of the day, it doesn't give you any other advantage, because still you need a pre-knowledge about what you have. The scan packet still might cause instabilities with the elements that are on the network, and still if you have firewall devices, not enabled devices and any other obstacles on your network, still those packets will not go through those. So basically active network discovery at the end of the day provides you with incomplete and in some of the cases inaccurate map of what you have on your infrastructure. Questions until this point? Because you have to understand what you have. The idea is that I don't want you to tell me what you have. I want my tool to discover it automatically. So if you have something that you're not aware of, the tool will understand what it is. It depends what you want to take out of it. I mean, a segmented day is nice, but do you need the information to be current? If you need to manage something, if you need to be able to do something useful with the information that you uncover, you need this information to be real-time. And active network discovery cannot be real-time. Yes? Exactly. Yes. is absolutely true. Um, so, going fast to another area of invention. If you didn't know, passive network discovery systems were first introduced in the mid-1990s. Don't let other people tell you that they were invented last year. Basically, passive network discovery system is merely a sniffer installed at the choke point of the network, processing packets that were sent by active network elements on the network. That's actually one of its biggest problems. So how can we look at the deployment? The system can be connected to the network using a tap like this one, a span port like this one, span port at the access layer, and span ports which are sent to one element. So what kind of information can be harvested? Basically, the information is about active elements that may show up in the inventory, active network services, the distances that those active network elements are from the monitoring point, the client-based software, the network utilization information, and, if possible, vulnerability information if this passive network discovery tool is doing. The kind of information or the purpose of collecting the information would be to build the layer 3 based topology, which is fairly problematic because what you need is actually the physical network topology, including the switches, including the hosts, to know exactly what you have and not just the layer 3 one, the network utilization information, some network forensics if the tool is able to do that, vulnerability discovery, to create some context about the network, and to feed that information to other systems. The strengths of the system is merely the ability of the system to be real-time, to have no impact over the monitored network, in the means that it doesn't send any type of traffic to the network, and there it doesn't pose any kind of risk to the network when it runs on. It can process packets and can process information from all TCP/IP layers, and it can detect anything that is active on the network, even if it's for a short time period. It can also detect elements behind network obstacles, so such as not enabled devices, firewall elements, and also can provide you with network utilization information, and can also useful for network-related anomalies. Who is using a system that it actually is based on anomaly detection? Cool. Are you happy with it? No, right? Because my anomaly is not your anomaly, it's not his anomaly, and that's the main problem. I'm not going to go into it, but I don't like it. Weaknesses. The first and biggest weakness of passive network discovery system is that what you see is only what you get. So if you have an idle service, if you have an idle system, if you have an idle whatever, that kind of element, that kind of information will not be uncovered. If the information does not go through the monitoring point, it will not be uncovered. It means that at the end of the day, the discovery will be incomplete and inaccurate and non-granular, because we cannot control what passes through the monitoring point. We cannot go to the client and say, you know what, we need you now to browse because we need the type of information that your browser sent to the network in order to build something or to conclude about something. We don't have any kind of control. We don't control the stimulus. So passive network discovery cannot detect all assets and cannot detect all protocols and services and cannot detect all ports. We cannot control what we see, and in order for us to detect something, well, you know what, sometimes we cannot detect it because the kind of information that discloses the type of information that we need may never pass the monitoring point. So another interesting subject, this is actually getting worse. Shut it off. Sorry? Where's the projector thing? You want to try it? No, he's recording. Yeah, you can do it. Nobody's here to press it, so just feel free to... Hey, it gets everything in all of those. Yeah, now we'll see. Tss. No, we don't want to do that. Sorry? Yeah. The Okay. Did you power it on? Okay, I'll continue. I have some modifications to the presentation. That's the problem. So basically, when it tries to build the topology, what it will do, it will look at the distances the elements are from the monitoring point, and it will look at the time to live field value with the packets it receives, and that actually would be the information that it will use in order to build the layer 3 topology. And you know what? Guess what? That actually does not help me, because if I see where the elements are and how are they located, and their what is their position according to my system, I cannot actually build everything, because I will have islands of information and I will not be able to uncover the exact routers that are actually operating on my network, and the only thing that I will be able to detect is those systems that actually send traffic to the network. Okay, now this projector doesn't work at all. That's nice. It's always the messenger. Okay. So if we have routing not done through the monitoring point, okay, it seems trying to work. Wow. Yeah, it's encrypted stream. I'll, um, I'm not mirroring, and it's 640 by 480. And I'll try to detect again. Oh yeah. Refresh rate is like down, like. Yeah, buy something else. That always works. Window. Yeah.
That's what the other guy said. If you had a presentation, he's like, "I'm here to do a Linux presentation." You know, it's all of them. So if you want to try.
1 second. Wow, that's really neat, right? Whew. Yeah, I'll do that 1 second. Yeah, I'll convert it to what needed. 1 second, we'll resolve that. It's gonna be components out here. Yeah, they are. This it works with Windows, right? See, I got an upgrade, so now I'm using Windows. Thanks for the help. A round of applause for the guy that donated his machine. Yeah, I want it back. Okay, here it is. Should I go to JD Travel, see what's in? Nah. Nice. Yeah, do it by telephone. That will be nice. Okay. Well, let's start from the beginning. At least you can see it now, right? Okay. So basically, if this is my network, and I want the passive network discovery system to draw it, this would be the result. Similar, right? I had this, and now I got this. The problem is that I will not be able to uncover the switches. I will not be able to uncover which machine is connected to which switch. And at the end of the day, I get this thing. I have a router, I have systems, hee. But actually, it's not my system. It's not my network. The problem is that we need to be deployed as close as possible to the access layer. We need to be see layer 2 traffic. In order to do so, it means that we need a lot of moving boxes. And to do this in, well, in a complete coverage, it means a lot of boxes and a lot of moving parts. So, another weakness is that I'm unable to monitor the state of network services. If this is an idle service, I cannot monitor it. If the service goes down, I cannot monitor it. At the end of the day, no service monitoring. So, for example, I might see traffic for a certain port. I may declare it as an open. The guy would close the port. I will never know it. So, the less obvious weaknesses are the fact that I can inject whatever I want to the network, and guess what? The passive network discovery system will take it. The problem is that there is no way for the passive network discovery system to actually validate the information. This is since the only traffic it sees, well, go through the monitoring point. It can't do anything. So at the end of the day, that leaves it with the inability to validate it. The problem with it is that it's not only influencing the passive network discovery systems. If there are other systems which rely on the type of information that the passive network discovery system actually provides in order to draw other conclusions, to do other things like network intrusion detection systems or even network intrusion prevention systems, that might be something which we don't want to be happening. This would actually cause the kind of information that will be taken from a passive network discovery system will cause other management systems that actually get the information from passive network discovery system to produce even more inaccurate and incomplete information when they process the information the system provides them. A very simple example to show you how this works. Let's say we have a Windows-based machine like the one here, and a passive network discovery system might have some kind of counter, or it might have some abilities to say, well, until I'm not detecting the operating system itself, I'm not trusting the information that actually is being sent through the different field values. So unless I understand that this is a Windows machine, I'm not going to trust the time to live field value. So what I've done is that I only played with one field. I played with the time to live field value. I changed it from default value of 128 to default value of 126. And all in all, that is still a valid Microsoft Windows machine. But for the passive network discovery system, it is now being located 2 hops down. I didn't do anything actually. I didn't move it. I didn't have to actually physically disconnect it from the place that it is being connected to. This is because passive network discovery system in this case is unable to go to the switch and ask the switch, okay, who's connected to you? So a simple example to show you that is very easy to trick the system. All you need to do is to understand the methodology and the way the system works in order to just put some decoys and deception and remove your system. Other weaknesses, denial of services, mainly because you need to take the information, open it up, and understand what you're seeing. Other examples of even remote code execution. Usually you will see this against Ethereal, which is a great tool, one of the best network analyzers out there, but some remote code execution is possible against it in its different versions. So, as some of you was in charge of a network, and I had a problem. I had a problem that I couldn't understand what I have. I couldn't understand what I need to defend. I couldn't understand where are my elements so I can understand what are the defenses that I need to do. I cannot build walls without understanding first what I need to defend. I've actually been doing this for the past several years and actually analyzed whatever there is to analyze regarding active network discovery, passive network discovery, and actually figured out that both of them will never help you if you want real intimate knowledge, complete and accurate about your infrastructure. Another interesting point is that there is many theoretical researches out there that actually they cannot be working on live environments, real world environments. If you remember the NAT researches, those all are good for paper. They don't really work on the real world, unfortunately. So the goals of the research were to have this kind of complete and accurate information, to have it in real time, to not have agents to detect and react to changes in real time, and basically not allow someone to send decoys that will be taken, but to understand that we have them and to ignore them, and to cover the entire IP address range of a network, and of course to have some other things like topology, which is really important. So what I've come up to is with a technology called dynamic infrastructure discovery. Basically, this is a technology that combines, tightly integrates actually between active and passive network discovery. And by tightly integrating between them, it has new discovery abilities that are not able to be made with each and every one of those if you use them solely. This technology actually is adjustable to any type of network that you are using. This is because it is able to balance between the information that is being harvested from a passive link to the amount of traffic it needs to send through an active link. It means that it works by listening to traffic that goes through a certain monitoring point on the network. It starts to build profile of the elements, data profile of the elements that's working on the network. And after a certain time had passed and it's seen that some pieces of data that were not being collected, or there are some pieces of data that cannot be collected through using passive means, it's actually calling the active side and surgically inserting packets into the network in order to get the missing pieces of information. So for example, if you want to know where your elements are, you need to talk to the switch. You can't do that passively. Or if you want to validate the type of information that you've seen passively, you do that actively. So at the end of the day, it balances between the type of information that it sees going through the monitoring point, which can be good, can be bad, and can be great. It all depends on the time of the day that you operate on or that you are at. For example, when your users are coming to work, 8 o'clock, 9 o'clock, everything is working, right? They do email, they browse the web, everything is fine. 12 o'clock, everybody at lunch, nothing works. 6 o'clock, everybody works. A lot of elements basically disappear from the network because people shut down their machines and go home. 2 a.m., you might see a lot of backup activity on a network. So at different times of the day, you see different things on the network that you are able to take different things from them about the elements. But at the end of the day, you need that information to be complete. So the balance comes from using the active side surgically probing. Other things that are unique, for example, you can detect what are the guest machine of a certain host machine of VMware or any virtual machine. You're able to tie them together. It's easier to detect not enabled devices and wireless access points using this technology. Basically, any piece of information that can be gathered either passively or actively can be gathered using this technology. You can build your asset management. You can do physical network topology because you're able to take the information that comes from the passive side, combine it with the information you are able to take from the switches and combine them into physical network topology where you show where the hosts are actually connected, the switch connectivity, and the routers. This is something that you can actually work with. You have a real-time change detection. You operate in real time because you have that from the passive side. You don't require any agents to be installed on the machines because your monitoring point provides you with all the information in the world that you have. Already talked about this. You are able to, one of the things that I like about this is that you are able to triangulate between user, host, and location. One of the biggest problems of managing and securing enterprise network is the inability to locate or the inability to say who's the exact user that's actually doing this and where it's actually his machine is being located at. So when you have the physical location information, when you have the host name and you have the username of the actual user that's actually been using this, it's very easy to come to someone and say, you are the one that actually did this and that, because you have all the information that triangulates that user to his machine. From using only surgical probing, this technology do not pose any kind of risk to production environment because you do not need to use a lot of packets in order to probe elements on the network for getting the information from, and therefore all the information is being either harvested passively or by using surgical active packets. So the number of packets they actually insert into the network is very low. The packets are RFC compliant, and there is no risk of using those against production environments. Some limitations. The only limitation that this technology actually have is that you can't really scan a network for 65,000 something ports, so you might not uncover all the services that are actually working on that system. Some usages. I'm being brief because I need to finish. You have clear visibility into your infrastructure. Everything that is on the network is being detected, from storage devices to host machines to network not enabled devices to wireless access point, everything. The accuracy level of the technology, let's say when we're doing OS detection, is less than 0.25% of false positives. The ability to locate any device on the network, see its properties, see its whereabouts, understand what is being doing, all done in real time, is something that you need as a context. And when you have physical network topology that you can locate everything, and when you have the audit information that allows you to see whatever everybody or that particular element is doing, you're able to understand what is happening, and if there is a problem on the network, you're able to locate it easily. So let's say that you're an admin and there is a new patch for a certain service. Usually what you'll do is you'll scan your network and understand where it is and try to understand what are the services that needs to be patched first. When you have current and real-time information, what you only need to do is just to have a search under your inventory for the open port. You get the list instantly, so you save the IT hassle of going and looking for that type of information. You instantly have the information that you need in order to work against, and that saves you a considerable amount of time. You can take the information and feed it to other systems. For example, you can do target-based vulnerability assessment. One of the biggest problems of vulnerability assessment tools is that they need to do active network discovery. So what you do is you're able to take a list of your Windows machines or Windows 2000 machines and instantly feed it to a vulnerability assessment tool, and that vulnerability assessment tool may need to do only the Windows 2000 based test against those machines, and that's it for it. So you actually are able to make those tools work better and solve the 80-20 problem for them by feeding them with contextual information about the network. There's also the ability to baseline the knowledge about the elements that operate on the network, because you see them all the time. So you're able to actually say what's unauthorized and what's non-authorized because you see everything. Until this point, if you're using an active tool, like this gentleman had said, if I do a scan once in 24 hours, I can't do anything with the information because I don't see the changes. There are some users that might bring their laptops from home and take it in between, and I'll never know that they're actually existing. I think the most important thing about the technology, about the dynamic infrastructure discovery technology, is that you finally have control. You can achieve control of what you have because you understand what you have, you understand the layout, you understand what you have a strong auditing capabilities, and you understand to use it for the first time, and not just saying, okay, I have partial information, I have complete information, I have control, I have everything that I need. Questions? Yes, the gentleman here. This is working. If you want more details, I'll give it to you on the end of the presentation. Other questions? If you'll talk to me after the presentation, I will answer the question. Yes. The only switches that you actually know that they exist, your core switches. I mean, in all the companies that I was talking to or working at or consulting to, what they know is they have a firewall that connects them to the internet, and they have those nice core switches because they cost them a lot of money. And usually when you hook this up to the core switch, you get all the information that you need from the core switch, and you go from there. Sure, it's something that you need to install on X number of places in a distributed manner in order to see the complete visibility, because it needs to see traffic between layer 2 to layer 3. But at the end of the day, you still see complete visibility. Say that you want to have an IDS system, an IPS system, they all have the same problem. But this system actually can take traffic from multiple networks into one place and not just see one network at a time. If you have a layer 3 barrier that you cannot pass, you need to install another system. Well, when you have a management server, you're able to connect everything and all the dots, and you have a complete information about everything. Yes. You must use SNMP to take information from the switches, because there is no other way to understand where the elements are if you're not using SNMP. The idea is that you don't need to know the connectivity, and you build the connectivity automatically using other algorithms. There are several researchers that were talking about how you build your topology by just taking the information from the switches and trying to connect the switches without using proprietary protocols. Some of them have some holes in it. Some of them are incomplete, but at the end of the day, you can learn a lot from those researches. What I did with these technologies, you must understand where the elements actually are connected to, and what you are able to do is just to say, okay, if this element is something that, for example, is unknown, and I'm able to say to which switch and which switch port is actually being connected to, you can use that information. And you can say, okay, I now won't go and tell an SSH and kill this port. The idea is to have the visibility. There are some switches that can send you an SNMP trap, for example, when the information about the switch MAC, excuse me, the source MAC that is being registered to the port changes. Not all of them are able to do that. The new Cisco 2950 are able to do that, but at the end of the day, if you want to start to do log aggregation, be my guest. I mean, there are other, products that do log aggregations and other open source tools, but if you don't know what you're doing with the information, then it's just a big pile of logs. Yes. To set what? Yes, it is possible in several cases to detect subs. Basically, the issue is that if you have a port which you see multiple MAC addresses and is not connected to any other switch, then guess what? You have a hub. Of course, that it might be a 4-port or a 6-port or 16-port, but no more than that. A hub is merely a guess, but if you don't have any other switch connected to that port, you basically have a hub there. Of course, you must be connected as close as possible to the access layer in order to do anything in networking and security these days. Yes. If you're using TTL, it means that you're gonna fail. That's something very easy to change, and you don't want to use that. Look at the example that I put here. VMware, you have two ways of doing that. You have a bridge mode and you have NAT mode. Both of them, you need to have different ways in understanding that you have VMware. I mean, it's very easy to understand that an element is a VMware machine just by looking at the MAC address and it's VMware, right? But the thing that you need to do is that you need to actually understand where it is being connected to, and that's other algorithms that I'm using to do that. Okay, so they need to, yeah, one other question. No, this works against whatever you put, and if you have VLANs, that's not a problem. If this wasn't working with VLANs, then I guess it was a major problem. It is working with VLANs, with everything they have on the network. So, I would like to thank you that you have stayed with me through all of the problems that we had today, starting late, replacing laptops, and staying up until 5 minutes to 9 p.m. Thank you very much for having me here. I enjoyed this.